The front right now says idle because we have not yet started the task. Right now, Ben is piloting the robot. He's going to walk the robot over to the starting position in front of the sequencing rack. This is also, I want to call attention, this is our prototype atlas that we're showing today. We also announced at CES the new robots over here, the new design with these static robots. But the one that we brought today to actually perform the work for you is our prototype. It's been a test bed for us over the last couple of years. We really put all the latest and greatest technology into the robot to be able to test it and prove that we can do this work. And the work that this robot is doing, it's doing right now in Hyundai facilities, including the Metaplan America. That is a real Hyundai part rack. Those are actual Hyundai roof racks for a Hyundai vehicle. So we've actually been doing a lot of work in those factories. That screen just switched to autonomous. This is currently autonomous behavior being demonstrated. So no one is controlling that robot. The robot knew from the demonstrations that in order to access the parts, it needs to lift that first layer of the rack. And you see there are several layers of parts. It knows that it needs to unload the full shelf, and each time it's empty, that it needs to raise the shelf and actually unload the next round of parts. Right now, Keelan is monitoring the robot in case he needs to interrupt. So you'll notice that he's using the VR goggles to track where the robot is looking. That way, if he needs to interrupt and collect more data, he can do it very smoothly. So now we're in a paused state. And now we're in a teleoperation state. So Keelan is now collecting more data. He's correcting an action for the robot. This will improve the robot. This is how Atlas learns. Every time we do this, the more data, the better, the more capable the robot is. This is not the only task that we're doing with Hyundai. We're actually going to use this new generation of robots to expand the tasks we're doing from automotive sequencing to other tasks such as order building, kitting, machine tending, and we're on our path to general assembly as well.
Brings us liberated everyday life.
And you can see that the robot's able to work in tight spaces. It's got 360-degree joints. So it doesn't need to move its legs. If it needs to turn around, it's just going to move its torso. A few specs on this robot. It's able to lift up to 32 kilograms. It's like roughly 68 pounds. It has a vertical reach of 2.3 meters. It's about 7.5 feet. That's also really important for reaching deeply into things. So the robot's very stable and is able to reach its body and grab things that are far away. It's got 56 degrees of freedom. So typical like static industrial robot arms has like 6 or 7. It's like 8 times that many. Many of them are of course in those dexterous hands. You'll notice that these hands have 3 fingers. We realized that that wasn't quite enough to do all the range of part grasping that we wanted to do in Hyundai facilities. So if you look at the new model, we now have 4 fingers. So that's one of the improvements. We also have tactile sensing in the new robot. So it actually has a sense of touch now. That will also be part of the data collection. That will make this robot even more capable. And you hear that loud noise? Does anybody know what that is? Yeah, that's right. It's cooling fans. The new robot doesn't have any fans. It's completely passively cooled. It's super quiet. And that's all done through the design of the internal structure to dissipate heat. So anywhere where you see striations on the new robot or ridges, that's actually heat sink fins. So through the clever design of the robot's structure, it's able to passively dissipate that heat. It also makes it able to work in extreme temperature environments, from negative 10 degrees Celsius to 40 degrees Celsius, which is pretty warm. So we're going to reset this rack so we can demonstrate this again. Run through it again. One of the interesting things about using these models is we don't have to restart anything here. The policy just says if you see roof racks, unload them. So once we restart the robot and put it back to autonomous mode, it's just going to say, oh, I see that once again the rack is full, and once again I need to unload it. We don't need to do any kind of explicit programming. And it's really amazing to think about, especially for those of you who are engineers yourselves, if you think about all the discrete steps you have to program. You have to recognize a particular type of rack. You have to know that you have to open the rack first. You then have to know that you have to grab the parts in a particular sequence. All of that it just does automatically through its behavior policy because it's been demonstrated. The robot does whatever you demonstrate. And that's what's really exciting about the future of retasking this robot. So you can imagine a future of, these Hyundai software-defined factories where you almost think of the factory as a giant robot itself, but the way that it actually gets work done is through many small robots that are all connected on the same network, working together collaboratively to do this work. And again, I think it's really special. This is day 3. You're some of the first people to ever see this robot outside of a Hyundai factory or outside of the Boston Dynamics lab. And my colleague Guy likes to say, this isn't a demo, you're witnessing an experiment, right? You're witnessing research in action. How we understand these new capabilities, how we understand how robots can learn. We mentioned our partnership with Google DeepMind and the Gemini robotics models we're using, and we think that the future is going to be like what we've seen with the large language models, where all of a sudden there was this breakthrough and there was going more and more. And you do that through data, right? The more data you have, the more capable these models are. But now instead of language tokens or letters or characters, we're talking about the action space of the robot. We're talking about perception data, the pixels that the robot sees while it's being trained, and also what's called proprioception data. Proprioception is your sense of where your limbs are in space without needing to see it. So the robot's able to obviously track its own actuation and understand its joint configuration relative to what it sees. That's why we also sometimes call these models pixels to torque. The robot sees a certain set of pixels, it knows what it's supposed to do next, because it's the most statistically likely thing to do for the demonstration, and all the actuation of the motors matches the next likely action. It's actually really cool in the teleoperation interface. You can see up to 1.6 seconds into the future. You can actually see the future trajectory of what the robot's most likely to do next. Nice work, Alex. Thank you. We also try to design these robots we want them to look like industrial tools. We're doing real work with these robots, but we also want them to be fun.